This is going to be a little bit different today. You're going to see me, but some pictures of the floor plan of the house and stuff. I'm not going to give the normal intro, but for those who might have not seen some of the rest of the channel, created this mainly to update friends and family on the build we're doing of a retirement home. And as a part of that process, there's some things that I went back and did, and I thought it might be kind of amusing to show these things. And so anyway, what I entitled this one is High School Math. Really? You know, because here I am retired and I find myself in the build of the house going back and doing things with respect to the high school math and some of the things that you learn in some of those classes. So anyway, that's what we're going to talk about a little bit. So the first thing I'm going to throw up for just a little bit is we're building an alternative home that's going to have dirt on top of the house and around the sides. For those who might have seen earlier technology descriptions of this, it'd be considered an earth sheltered house, kind of an elevational design, but a little bit of a burned type design as well, and not just purely one or the other. And I'm showing you basically what the floor plan of the house is with the main house, and then with the garage and kind of workshop area that's on there. Now, I want to give you a little bit of background of a couple of things that are important to know about how you have to lay the house out with this particular design. So you can see that I've marked around in red on here, and I've numbered them V1 through V5. So there's 5 vertices points, as they're called. They make the radiuses for where there's kind of radial things done within the floor plan, but they're also used to be primary measuring points about how the house, the layout is. And so those things are going to be important as we go through some of this. The next one I'm going to show is, again, full floor plan, but I showed 3. There's really probably a 4th one you'll see in a little bit, but there's basically sort of some center lines. You've got the one that goes through the 3 vertices that are in the main house, one that goes off of that center line up to the pantry vertices, and then you've got one between the right-hand vertices V3 V4 and the V5 vertices out in the garage area that's in there, and we'll be using some of these things to be able to go through there. So with that, let me get in real quick because I don't want to take up a lot of time going through these things. But when you're wanting to lay out the vertices, when you're laying the house out, one of the things as a background that builders do is you'll typically lay out your rectangle or square, and you have equal sides on the opposite sides from each other that are parallel to each other, and then they'll take the cross between the 2 opposite points and they'll call it squaring up. And so we're going to use that technique to be able to do some of the things that we did with the house layout that's there. But first, using some of the vertices points and trying to figure out and make sure we get things laid out correctly, there's a couple of ways we could approach things, but I'm going to go through a couple of things real quick. These are a little bit repetitive in these first 3, so I won't dwell on the second 2 quite as much as the first one. But as you see, I drew a line, light blue line, that goes from vertices 1 through vertices 2, and then over another 6 feet 5 inches basically, and then it goes up to the vertices 3, which is up in the pantry. And then I drew from vertices 1 to vertices 3, which creates a right-hand triangle. And so with that, we know, let me put these on so I can see this a little bit better. We know the distance that I've got labeled as A, which is across the bottom of the right-hand triangle. We know what the distance of B is based on what's laid out here within the diagram. You should be able to see those. And then we needed to know what that hypotenuse was, the letter C that I show in the diagram. So we're going to use the Pythagorean theorem, high school math, to be able to figure out the length of C. So knowing A, knowing B, and what those distances are, we can square both of those, add them together, and then you've got the square of what C is. So you take the square root of what that sum is, and you come out with what the distance of C is. So one approach we could take in being able to make sure we lay this vertices out properly with respect to that is to go back and do the square. We have an A and a B height, and we could create a rectangle. Now we know the hypotenuse distance between the two opposite corners, and so we could square it up, V1 to V3. We can do the same thing. As you look on this diagram, we got V2 to V3, and you could do a similar thing. And then also, finally, you could also have V3 to V4, which gets you out to that right-handmost point vertices in the main house. And you could do any of those as squares and square them up and really get that in there saying, or the other thing you can do is just compute the hypotenuse for each one, measure from each of the vertices points that are there, because since V1, V2, and V3 are in a straight line, you can get them, lay them out, mark them off. Now you know what that distance to V3 is from V1, V2, V4, and the line you've created there, that center line. And now you've got your center line going up, and by taking the hypotenuse and measuring from each of those other vertices when they all hit the right distance, it's almost as good as squaring up. So that's one way that we could do it. The second thing that we do in doing this is, you see that I've got here a real quick snapshot, and then I'll move to the next slide. Over both on what's the master bedroom side and what's the guest bedroom side, there's these little small jut outs, which is where you're able to install doors, get light in, meet the fire code for being able to exit by having the appropriate area and stuff. Well, what we needed to be able to do here is we needed to be able to lay those jut outs off properly. One of the things that you can see is we've got an angle of 22.5 degrees coming off of the horizontal, but you see I've created in yellow. Again, we're going to have an A, B, and C in here, but we create a triangle and we compute those sides. So here we don't use the Pythagorean theorem to start with, because we know what the distance of our hypotenuse is from the vertices out to the outside edge of that, which is creating a center line down the middle of that little jut out. And so we create our right triangle. I've got X on the right-hand side going vertical. I've got Y as the horizontal. So here we begin to use sine and cosine. So with the cosine, we can compute X. You can see the formulas there, and you can get what the value of X is. And you can do similar with using the sine instead of the cosine to be able to get the Y coordinate, as I called it, in there. What you can do then is you can actually create a box, because you can come off vertices 1 back to the outside edge of the radius by the value of Y, and then you should be able to come down X into what that hypotenuse distance is, and then measure the hypotenuse on the box. You've now got that center line coming out from the vertices, V1 in this case, you'll have V4 in the guest bedroom, and then we know the distances off of that center line to be able to compute the outside edges, and so at that point you can create what's the jut out on there. Now, the next phase that we did is we needed to be able to lay the garage out, which is also on an angle. Now, in this case, again, we know from vertices 4 to vertices 5, which you can see, we create initially our calculations. We know what the hypotenuse is. We know, again, that we're going to use a 22.5 degrees angle that's going to be coming off of vertices 4. And so at that point, again, we can use the cosine to compute the X value as shown. We can use the sine to be able to compute the Y value. And then at that point, We create two parallel Y's, two parallel X's. We know what the hypotenuse value is, and we square the box. And so that gives us vertices 5, and it's now in location without having to have any fancy equipment that can actually do the angle measurements for you and the distance measurements and all that you can do with some laser equipment. Now, that got us vertices 5. As you're going to see, I created 4 points, G1, G2, G3, G4. Those are points to be able to lay out the garage, really. And so what you see on this next slide again is, and this time we're going to use a different angle than 22.5 degrees. We find on the diagram that we've got basically an 18-degree angle coming out of vertices 5 down to what the G1 point is down here, where the laundry mud room actually meets into the garage. And so again, what we need to be able to do is we need to be able to create, in this case again, a kind of an X and a Y or A, B in there, and the hypotenuse for this. Well, we know what the hypotenuse value is that we want to have, which is 18 feet and 7 inches. We know our degree angle of 18 degrees. And so again, we use sine, cosine. We create the two sizes for the sizes of the boxes. We create the parallels based on those sizes. And then we know the hypotenuse of 18 feet, 7 inches. And that gets us G1. G2's opposite of that, 180 degrees out. We can do a similar thing to be able to mark the G2 coming off of here and compute all that and lay it out. And so that's the thing that we do there. Finally, we needed to be able to do the rectangular part of the garage, which again's on an angle that you have coming off of this. But in this case, we know what the sizes of the square are. So we know we're 37 feet 2 inches across the width of the garage. We know we're 18 feet 10.5 inches coming down the sides at the angle like this. So we know what that is. So again, we go back to the Pythagorean theorem, knowing that, and we compute what the hypotenuse would be. And so we lay the box out, we take the hypotenuse, do the square measurements, and then what happens is we now have the layout of the house on ground without having to use a bunch of fancy equipment, utilize the skills that the contractor has, and to be able to do that. Now, just so you'll know, we did have an engineering company come back in and lay out points using some fancier equipment just to double check what we did, and it worked out very well. We were off just very minor amounts based on rounding of calculations and then measurements with, basically tape measures and stuff like that. So that kind of explains that here I am, even in retirement, building a retirement home, and I still find myself going back to high school math. Hope y'all enjoyed this, and we'll catch you the next time. Thank you.